Howdy, y'all. I am so sorry I'm not there again. But I wanted to go over the homework quiz that you just took while it is still fresh on your minds. If you think you've got this stuff down, you don't have to watch this whole video. I'm going to go through each of the 3 different types of patterns. If you think you have that down, you can just go look at the key to the homework quiz, which I'm also posting on Canvas. And if you totally get what you're doing from that, by all means, call it good there, and then you can go work on Module 1.3, work yourself through that, or start working on that project. But if you need some guidance, well, here I am. Let's do this. So here's the first one. Wait, y'all, have you said your daily mantra? If you haven't, you need to, you should. Go ahead, stop, and do it now. I'm in a hotel room, so I can't yell too loud, or else my neighbors are going to get mad at me. But I know that I am good at math, and I know that you are good at math. So go ahead and pause it, say it to yourself, and then come back. Okay, welcome back. So here is our first problem. So what kind of pattern is this? So I'm going up, I went from 3 to 5, so I'm going up by 2 here, and then I went up to 7, so I went up by 2 again here. So what kind of pattern is that? If you said linear, you are correct. And y'all, how do we know that it is linear? We know that it's linear because it has the same first difference. The first difference is the exact same. So it's going up, it's adding the same thing each time it moves forward a step. So what is the generic function for a linear pattern? Anyone? If you said y equals mx plus b, you are absolutely right. Go ahead and pause this. Hopefully your neighbor is watching this at the same time as you. Pause this and tell your neighbor what the m stand for and what the b stand for in y equals mx plus b. Go. I'm going to assume that you have told your neighbor that the m stands for the rate of change or the slope, and that the b stands for the start value, which is, in fact, step 0, 0, 0, 0. Okay, so what is the rate of change for our fancy little equation here? What did we add each time? We added 2, so that's 2x. And then what's our start value? Wait a second. We have year 1 right here, but we do not have year 0. So, y'all, how can we get to year 0? What do we need to do to go backwards? If you said subtract 2, you're exactly right. You win the prize. Since we're adding 2 to go forward, to go backward, we're going to subtract 2. So we had 3 trees here. How many trees are we going to have over here at step 0? You're right if you said 1 tree. Here he is, right here. Hey, little tree, 1. Okay, so let me go back over there to finish up my equation. This is going to be 2x plus 1. So that is my explicit equation. I think we should put that in a 3D box. Good. Now, what about recursive? Y'all, what is recursive? Did I say that this was explicit? This is the explicit. Explicit. What about the recursive formula? What does a recursive formula always start with? It always starts with f of x equals f of x minus 1. And remember, this just tells me, hey, to get to f of x, I need to go back to x minus 1. So I'm going back to the previous step, the time before, to get to this x. Stepping back to the previous step, and then what am I doing right next to that? I'm applying the pattern. So in this case, the pattern was plus 2. Now, in every circumstance, you need to list the starting point along with your recursive function. So the starting point in this case, we've already said, was 1. Y'all, you should be writing this stuff down on that handy dandy pink or like salmon colored sheet that you have. If you mess some of this up on the quiz, like get out your highlighter and highlight this and be all like, oh my gosh, that's too much. I was highlighting too much. I need to remember to put the starting value, or I need to remember that this is M and this is B. Make sure you can tell me or tell yourself later on that you know what to do. Okay. I'm going to skip the next one because it's basically the same as this one. We're going to go to example number 3. So go ahead and head over there. So here we are, number 3. Now, I hope this wasn't too confuzzling for you. I wanted you to count the gray triangles. Hopefully you didn't try counting every single triangle. Otherwise, well, I'm sorry if you did that. So let's just count how many gray triangles we have. I have 3 triangles here. 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles here. 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to pretend I counted all of those. There are 27 there. Okay, so the best thing to do, I know that you want to just look at this and say like, oh, we're just multiplying by 3 every time I go forward. That's true, but you should also check out your first and second differences just so you can double check to see if it's a linear or a quadratic. So I know that this is an exponential type of an equation, exponential, because I'm multiplying, right? I'm multiplying every time, which means exponential. So for the explicit, does anybody know the general form? I like the way I say, does anybody know? And it's just you watching your Chromebook. Hey, do you know what the general form of the explicit function for an exponential function is? Do you know? Think, reach way back. You learned this last year. I know you did. Okay, I'm going to tell you. It is y equals a times r to the x. So what does each one of these things mean? This guy, I don't know why we use all different letters. Somebody write a letter to the math people and ask why we use all different letters. It's weird. So this guy is our start value, which remember is step 0. And then this guy is the rate of change. So in this case, what are you multiplying by? What are you multiplying by? That is the rate of change. So, Shuckleface McGee. Again, if I assumed that this was step 1 right here, this was step 2, and this was step 3, I don't have step 0, and I need step 0. So, here's what we need to figure out. What can we do to go backwards to get step 0? Well, if we're going forward, we multiply by 3, then to go backwards, we're just going to divide by 3, y'all. So back at step 0, what's 3 divided by 3? If you said, wait, what did I just say? 3 divided by 3. Oh, right, 3. My brain, y'all. Oof, it's almost Friday. It is Friday for you. Oh my gosh, I'm talking to you in the future. Incredible. Sorry. 3 divided by 3 is 1. So there is exactly one little triangle over here on step 0. So let's go ahead and let me go back down here and make the triangle, make the equation. So this is going to be y equals, my starting point is 1 triangle, my rate of change is 3, and then it's raised to the x power. That, my friends, is the explicit equation in our little 3D box. Now, for the recursive equation, we're going to do the same thing. We're going to start it with f of x equals f of x minus 1. And then this time, our pattern, instead of adding something, we're times by something. So I'm just going to say it's times 3. And then as always, I'm a little bit out of room, so I'm just going to squeeze it in down here on the bottom. As always, I'm going to list my start value, which is f of 0 equals 1. Okay. What I would like for you to do, look at this, think back to what you just did on your quiz. If you did something different or you left something off, get out your highlighter and, highlight all the things, what you did wrong, what you need to remember. And then I want you to go to the next one, example number 4, and see if you can do that. I'll give you a hint. It is an exponential function. So go look at example number 4. See if you can write the recursive and the explicit equation for those. I'm going to give you the answer in about, by your watch, it's going to be about 7 seconds. So go do it and then come back. Okay, here's example number 4. Hopefully you've already done this because I'm about to put up the answer. First, can anybody tell me the pattern? What do you think the pattern was? Indeed, we were dividing by 2. Now, remember, dividing by 2, because we want to stay away from division. Exponential has to do more with multiplication than division. So how can we represent division as a multiplication problem? You can times it by 1/2. It means the same exact thing. In fact, let me just make a little quick note up here. If you divide by 3, that's the same thing as timesing by 1/3. If you divide by 5, that's the same thing as timesing by 1/5. If you divide by, 17, that's the same thing as timesing by 1/17. So you see that pattern? When you divide by a number, it's the same as multiplying by the reciprocal, which just means the flippity-flip of that. So that's very handy to remember. So let's go back and look at our explicit equation. Y equals a times r to the x. What is our start value? We're so lucky that we actually get to see our start value this time. Here it is right here. When the x value is 0, step 0, that's our start value. So, oops, that's a highlighter, not a marker. Here we go. So y equals 4 is our start value. Then our rate of change is 1/2, so times 1/2 raised to the x power. That is your explicit function right there. And then your recursive, let me see if I can just pop this up real quick. Boom, done. That is your recursive. Again, don't forget to include your starting value over here with your recursive. Okie doke. Okay, I think we're ready for the big guns next, y'all. It's time for some quadratic. Sorry, I tried to be dramatic. Okay, let's go to the next one. Okay, here we are at example number 5. So let's do some counting. Let's see how many little tiny football helmets we have here on example number 5. I count 3 little football helmets here. I count 1, 2, 3, 4, 5, 6, 7, 10 little football helmets here. I count 1, 2, 3, 2, 3, 4, 5, 6, 7, 21, and then I count 1, 2, 3, 35, 36, 30 shekels. I think it's 36. 36. Okay. So, y'all, I don't see an obvious difference as far as multiplication goes. So I'm going to calculate first and second differences, which you should be doing already anyway. So 3 plus what will get me to 10? 3 plus 7, right? 10 plus what will get me to 21? 10 plus 11. 21 plus what will get me to 36? That is 15. So those are our first differences. They're not the same, so I know this is not a linear function or linear pattern. Let's look at our second differences. I'm trying to find a good color here. Let's do this one. Okay. Our second difference is 7 plus what gets me to 11? That's plus 4. And then 11 plus what gets me to 15? Plus 4. Guys, what do you notice about those second differences? Y'all, they're the same. So what that means, since the second differences are the same, this is a quadratic function. And the quadratic function has a form y equals ax squared plus bx equals, oh my gosh, not equals, plus c. That is your standard form. So what we need to find is what A equals, what B equals, and what C equals. So let's do that real quick. If you will recall, A is equal to 1/2 times the second difference. So what is the second difference in this case? If you said 4, you are correct. So it's 1/2 times 4, which is 2. So I know that A is equal to 2. A equals 2. And then I know that C is equal to the start value, which is step 0. So in this case, oh, Shuckleface McGee, y'all, they didn't give us step 0. They started us with step 1. I'm just going to assume anytime that I have pictures and diagrams, y'all, that the first thing I get is step 1, step 2, step 3, step 4. So this is a little tricky. So pause this real quick. I would love for you to think about how you might, that's right, I just moved the whole thing because I'm magic. How you might be able to go backwards to find step 0. How many football helmets are going to be there? So talk with your neighbor real fast and then come back. Okay, what did you guys talk about? I can't hear you, so I'm going to assume that what you said was, Miss Wright, the difference, the common difference right here that we're seeing on the second is +4. And I would say, yes, you are correct. That is +4. So that must mean that this difference right here from 7 back to whatever that was also +4. So what +4 gets you to 7? Y'all, that was 3. So that must mean my first difference between this little guy right here, the 3, and whatever this is over here was a difference of 3. So what number +3 got me back to 3? If you said 0, you are correct. This is empty. This guy right here, empty. Nothing there. There are no helmets there. So my starting value is in fact 0. So I'm going to go back down here, C equals 0. Okay, now we need to find the B value, which is slightly difficult. So I'm going to, what do I want to do? Let me make it even smaller. Whoa, this is crazy. Okay, so the B value, what I need to do is plug what I know into my standard form, which is right there, and I need to pick an X and Y value from up here. So if we were to turn this diagram into a table, y'all, this is what it would look like. I would have my X's, my Y's. Here's step 0, 1, 2, 3, 4. That was 0, 3, 10, 21, 36. So which one of these points, that's not the starting value. I can't use the starting value. So which one of these points do you want to choose to find our B value? I like to use the one that's going to be easiest, which I think is going to be this puppy right here. So the 1 is my X, the 3 is my Y. I'm going to plug that in right here. I also know my A and I know my C. So let's plug and go. So Y is 3, equals A is 2, X is 1 squared, B, and then 1, and then C is 0. So I've just plugged everything in using this equation right here. I plugged in my 1 for X, 3 for Y, 2 for A, and 0 for C. And then I'm going to find B from all of this. So let's keep going. I have 3 equals 1 squared is 1, and then 2 times 1 is 2, and then B times 1 is just B, and then I'm not even going to include the 0. Now to get that 2 right here back over yonder, what do I need to do to move it back over here? I need to subtract it. So minus 2, shoo, shoo. So 3 take away 2, I believe is 1. So that means 1 is equal to B. Boom, we have found our B value. So after all that, we can write our final quadratic explicit equation, which is Y equals A is 2, X squared, plus 1 is B, so I'm just going to put X because there's just one X. And then plus 0 is my C, so I don't even need to include that. Shablamorama, I am finished. Okay, y'all, I want you to stop this, pause it, go back if you need to, and then I want you to go to the next one. I'm just going to show you the answer here in about 10 seconds on this video. So go do the next one, and then, so pause this, do the next one, and then come back and check your answer. Okay, guys, here's the next one. I just put it all up there for you. So if you need to pause this and look at what I did, feel free to do so. I found the first and second differences. I found my A term, my C term, which is the 0 term, it's right there. And then I plugged everything in to solve for B, which led me to my final equation. So that's my quadratic equation. Okay, if you made it to this point, good job. Give yourself a pat on the back, because dang, that was a long video. Y'all, I'm posting a bunch of notes online about multiplying binomials, about doing this stuff, as well as what else did I post online? I don't know, just look on Canvas. There's a lot of good stuff. I will be back next week, and we can talk if you have any questions about the project. I'll let you know. Y'all, I hope you're having a fantastic day. Be nice to the sub. Stay on top of things. And I will see you next week. Have a great weekend. Deuces.